When it comes to water cooling PCs, there's three most common objectives that enthusiasts build towards: looks, performance, and acoustics. Now, this is not the kind of problem that require you to pick only 2 out of 3 or sacrifice one in favor of the other. Everyone decides for themselves what they value the most and then optimize for that thing, or all three if that's what they're going for. But for me, I like my systems as silent as possible, which is why we'll modify this motherboard with an aftermarket contact frame. Now, before we do the procedure, let's first talk about what problem this bracket solves in the first place. If you look at Intel CPUs, then you'll notice that they have these two tabs on the side. These tabs are used to push the CPU against the socket enough that all of its 1700 pins make a proper contact with the pads on the CPU. And herein lies the problem. Because the default CPU retention bracket presses against the CPU just on these two tabs, the CPU itself bends a little. Now, we're talking 20 to 50 microns here, but this concave shape is already enough that the contact between the CPU and the cooler we put on top gets worse exactly in the spot that we need it to perform its best, in the middle of it. But it gets worse. Without going too much into material science, most materials deform in two ways: plastic and elastic. Elastic isn't as important for our case because, well, elastic material returns back to its original shape once the forces that deformed it in the first place are removed. But plastic deformation, on the other hand, means that after the material is deformed, it'll stay that way. And what's also important for our case, plastic deformation often gets worse with age. So how does this apply to our CPU? Well, when we lock the CPU in place, the default retention bracket, keeps pushing down on these two tabs, well, for the lifetime of the CPU. And while, yes, some of the deformation is elastic, some of it is plastic as well, which means that the CPU will bend not just initially, but also additionally over time. Now, for most people, this isn't that big of an issue, simply because we're talking micrometers here, which will add up to maybe a couple of degrees over, I don't know, 5 to 10 years. In this kind of lifespan, accumulated dust in the computer will most likely make the situation far worse than the bending of the CPU ever could. But for some of us, these couple of degrees matter. Because, like I mentioned in the intro, if I can get my CPU cooler regardless of by how much, then I can slow the fans down and thus get closer to my goal of having a silent PC. So why is this not a problem for AMD CPUs? Well, because unlike Intel, they don't have the two tabs on either side, but rather have them all around the CPU, which means that the retention bracket that pushes down on the CPU does it equally on all sides, avoiding the bending problem altogether. Now, I know what you might be thinking at this point. Why don't Intel motherboards just ship with a bracket like this, aftermarket thermal right, in the first place? And I guess I've already given an answer to that, at least partially, because the couple of degrees that we're gaining with this mod usually don't matter to 99% of the people, but maybe even more importantly, there's a certain risk when it comes to installation of this bracket, since we have to remove the original one and risk bending any of the 1700 pins that are on the socket. And if we do, the motherboard, well, it's pretty much gone. And it would suck destroying a $700 motherboard like this one. Now that you know what kind of perfectionist I am when it comes to PCs, you're probably wondering what kind of cooling I'm going to use on this Intel i9-14900K, which is notoriously hard to cool. Glad you asked, dear viewer, but before I give you an answer, can I kindly ask you to click that like button? Go on, I'll wait. Thank you. And now to answer your question, we're using this AlphaCool Core 1 Black. Yes, black, because I'm too old for RGB, but more importantly, because this motherboard is going into a rack mount case. Yes, I'm building a water-cooled rack mount PC, and according to my research, this water block is A, gorgeous, well, I didn't need research for that, and B, measured to be one of the best performing CPU water blocks on the market. I'll leave a link to Der Bauer's video down below so that you can see the results of his measurements and analysis for yourself. Again, just like with the retention bracket, the use of this particular block allows me to achieve like maybe 3 degrees lower temperatures, which for most people won't matter, but for me, if combining the two brings the temperatures down, I don't know, for like 5 to 6 degrees Celsius, then this means that the fans can turn 200 RPM slower, which, you guessed it, makes the system quieter. By the way, full disclosure, all of the components I'm using in this video were sent to me for free, and I do get to keep all of them. But no money changed hands, and I'm not required to say anything good or bad about any of these products. All the PC parts you see here were provided by Ani, who are specialists not just in PC parts, but also in other IT solutions such as cybernetic security and data recovery. I know them personally and I highly recommend them. And as for the water block, and the rest of the water cooling components for this build for that matter, they were provided by AlphaCool. AlphaCool I don't think needs a lot of introduction. They make some of the best PC water cooling products in the industry, and I'll leave the links to both Ani and AlphaCool down in the description. Okay, let's now first put the CPU in as it was intended with the original retention bracket. And we'll do this for 3 reasons. First, if you watched any kind of PC building tutorial so far, then you probably remember how all of them advise you to not remove the black plastic cover by yourself, but let the CPU push it out when you close the lever. You know why? Because if you remove it by hand, which you totally can by the way, then you risk bumping it into one of the CPU pins and potentially damaging the motherboard. Second reason is that you'll be able to see how, or should I say where, the original bracket pushes down on the CPU. And third, much like the first, we want to keep the CPU in place while we're replacing the original bracket in order to protect the pins during the procedure. Luckily for us, this aftermarket bracket already comes with the correct wrench and has this triangle drawn on the bottom left to let us know how to position it correctly. And additionally, you wouldn't be able to put it on incorrectly because the distance between the top 2 holes is shorter than between the bottom 2. Now here's where we have to be extra careful, because we don't want to strip any threads here or over tighten any one screw compared to the others. Doing so can and will result in an uneven mounting pressure that could potentially damage either the motherboard or the CPU, which is why I need to go around either clockwise or better yet in a star pattern and turn each screw roughly 90 to 180 degrees before continuing on to the next one. Once I reach enough resistance in which I cannot turn the wrench with 2 fingers anymore, then I'll just apply another 90-degree turn with a bit more force and leave it at that. I already went ahead and installed the backplate that serves as a sort of an anchor for the screws that hold the water block in place. So let's now install the standoffs that will prevent the backplate from moving around while we install the water block. Again, there is no need to over-tighten anything here. In fact, the installation manual explicitly says that we shouldn't use any tools when installing the water block. And while the box with the water block also includes a small syringe of the AlphaCool Apex thermal paste, I really prefer using my Thermal Grizzly Cryonaut Extreme. I hope you're seeing the pattern here by now. I know that the included thermal paste is perfectly adequate for the job, but I know that the Cryonaut will give me maybe a 1 degree edge, which again is almost nothing, but not nothing. And another degree gets added to my mission of having a silent system. There we go. All that's left for me to do now is put on the water block on the CPU and tighten the screws again by hand only. Now, before we wrap this video, let's also install this 32GB RAM kit from Kingston. Now, this video is not meant as a tutorial, but I can't help myself from mentioning the importance of putting the RAM sticks into correct slots, because otherwise you're leaving performance on the table. If you have only one stick, then you need to put it in the slot closest to the CPU, but if you have 2, then you need to put them into the second slot and in the 4th one. And finally, now let's put in this 2TB SSD from Samsung. Here too we have to be very careful not to put it in just any slot, because this motherboard in particular will split the PCIe lanes between the primary SSD slot and the GPU slot if you populate both. So what I need to do is not use the primary SSD slot and use literally any of the secondary ones. This isn't a problem because the primary SSD slot is PCIe 5 and we don't need it because our SSD is only PCIe 4, which literally any other of the 4 remaining M.2 slots will do. So, was putting an aftermarket frame on this $700 Asus motherboard worth it? Well, for that, you'll have to check back to this channel in a couple of days because, as I said, I'm building a rack mount water-cooled PC and, you know, making one super long video would take forever and likely would not be a very enjoyable viewing experience. So I decided I'll cut them up in 3 or 4 parts. But for now, Tomasz from Slovenia, signing out.